Hi, today we are going to look at comparing functions. So comparing the initial value and comparing the rate of change for different functions. Now, often when we talk about initial value or rate of change, we're talking about some kind of context. So maybe there's a word problem associated with each of these. For today, I'm just going to show you straight up how to compare initial value and rate of change for a graph table or equation. So first off, initial value is really just the y-intercept. So if x is 0, what is y? So if you're asked to compare those, maybe it just says compare them. Maybe it says which initial value is larger or which initial value is smaller. So you have to read what does the question ask. Then you have to find the initial value or the y-intercept of each function. So the equation is really easy. The initial value is -4. So I don't know, maybe I'll type that out. Here, let's get rid of that. Initial value is -4. And then now down here, we don't actually know the initial value. It doesn't give us if x is 0, so we have to work backwards a little bit. So if I go back 2, I can go back 2 again to 0. And here I actually, same thing, I went back 2, so I went back 2 again to 0. So that's great. The initial value is 0. Equals 0. And then the last one is looking at this graph. The initial value is the y-intercept, so where it crosses the y-axis, that happens to be 2. So initial value equals 2. So now, to compare them, it would depend on what it said. If it said which one is the smallest initial value, well, then the equation is the smallest initial value. Which one is the greater or the bigger or the larger initial value? The graph is the largest one. If it just says compare them, then I would write, well, the equation has the smallest initial value at -4. The graph has the biggest initial value at 2, and the table had an initial value that was in the middle at 0. So that's comparing the initial values. Next is the rate of change, which rate of change is just slope. So for my equation, it's nice and easy. My rate of change, again, it's just the slope, so it's just 3. Next is going to be my table where rate of change is slope. I have to choose 2 points. And when I choose 2 points, it has to be 1 point is an x and a y value. In this case, the table is sideways. So my x and y value is like this. There's 1 point. Here's my second point. Now I subtract the first y value minus the second y value. So 2 minus 4 is -2. And then I do the same thing for the x values. The first x value minus the second x value, 2 minus 4 again is -2. Simplify as much as I can, and that is 1. So I now know that my rate of change, which is just the slope, is 1. Let's see if I can move that. Yep. And then our last one is going to be this graph. Find 2 nice points, doesn't matter where they are. Rise over run, I go up 2 to the right 1. So 2 over 1, I can simplify to just 2. So my rate of change, which is just my slope, rate of change, my slope is 2. So then if the question asked which one is the largest rate of change, the equation is the largest rate of change. Which one is the smallest rate of change? The table is the smallest rate of change. Or if it just says compare them, then I would say something like, the equation is the largest rate of change with a rate of change of 3. The table is the smallest rate of change with a rate of change of 1. And the graph had a rate of change right in the middle with a rate of change of 2. So that's comparing initial value and rate of change for a graph, table, and equation.